Great. 2 talks to the end. It's been a great day. Lots and lots of knowledge. How do you say your name?
Wojtek.
That's the one.
The surname is better one, Barczynski.
Okay, thank you. So yes, you're going to talk about LiveCompositor.
Yeah.
You keep confusing me. So yeah, I'm really excited about this project. I think it's going to be really great for many use cases. So I'll hand it over to you, and we'll come back for questions afterwards. Thank you very much.
Big Bug Bunny, and in those 10 minutes that I haven't been doing that, I've been working on LiveCompositor and Membrane. Aside of that, I enjoy playing extreme sports like chess and scat. And today, I'm going to talk about mixing WebRTC tracks. But before we go into the mixing, let's ask the question why you want to do it, why you would want to do it in the first place. So, most of the WebRTC servers currently are SFUs. So it works like this, that a single client publishes their video and audio tracks, and it receives selectively forwarded tracks of the other peers in the meeting. But if you want to stream it or record this meeting, the clients want to receive a single stream, right? Either it's going to be a HLS, a playlist, or MP4 file. So we need something that takes those multiple tracks and combine them together. So what we can use for it? 2 years ago, there were just those options. So basically, you can either spawn a headless browser, something like Chromium, use GStreamer, FFmpeg, or OBS for it. And let's take a look at them. So let's say with the Chromium, it's by far the most popular choice. You just spin up the headless browser. Usually, you connect the peer to the meeting that doesn't send any immediate tracks and just receives them, mix them in the browser, and oppose them somehow. And using it have some pros. So basically, you can render anything that browser can render. So it's kind of great. You can have all the power of HTML, CSS, and JavaScript. But on the other side, the overall setup is quite complex. Deploying it isn't as simple. There's performance overhead of running it on the browser, on the whole browser on the server. And so let's take a look on the other options. You can use GStreamer and basically create some similar pipelines to this one, where you take some receivers, demark the video and audio, decode it, put video to GStreamer Compositor, put audio to GStreamer Audio Mixer, and there you mix it, marks it back, encode it, send it. So GStreamer Compositor allows you to specify options like a position of the video, with its width, height, the alpha, which is like transparency level, and the order which videos are on top of the other ones. And Audio Mixer allows you for volume adjustments. So deploying is quite simple because you just deploy a simple GStreamer pipeline. But on the cons, it doesn't support complex compositions. You can do really animations. If you want to add text or images, you have to use separate components for that. And if you want to modify this composition on the fly, you have to either unlink these paths or change their options. So it's quite hard. Similarly, you can use FFmpeg filters, something like HTAG, VStack, overlays, and some other ones, and AMix for audio mixing. And you get basically the same trade-offs as before. So quite easy deployment, but on the other side, limited capabilities. There's also OBS, which everyone uses for live streaming, right? But the con of using OBS is that it's not really programmatic. It's configured in GUI. So you have to script it if you want to run it on the server, right? Or use libOBS, which is a mess a little bit. So there is some pattern here. And I'm not talking about the pattern that Sean worked on this project. This is not the one I want you to see. Is that those tools are either easy to use and provide you with simple composition, or are quite more hard to deploy, to use, and there you can do more complex stuff. So we saw this gap in the market and decided to create a new one, the new tool for that. And this is how LiveCompositor emerged. It's basically a media server for low latency, real-time programmatic video and audio mixing. It works like that you stream to it video with RTP, or just video and audio with RTP, or register MP4 files. You provide some specification via HTTP request, and you get your output streams mixed back in real time. So here we can see how you can provide a specification for the composition. You send it via basic HTTP request. It's in the body. So we can alter things like the layout, we can add images, text, backgrounds, and if we want some custom effect, we can write our own shader, and register it, and run it directly on the GPU. But we want to cover most common use cases without the need to understanding the shaders and to writing them yourselves. So what took us those 2 years? Because it doesn't sound like that hard of the problem. So the hard parts were performance, synchronization of the streams was kind of an issue, and coming up with really intuitive API. So for the performance, this is how it looks underneath. You have some RTP receivers, decoders, queue for synchronizing the streams that I'm going to talk about later, renderers, an audio mixer, encoder, and sender. And basically, most of those elements work on separate threads. We also do some congestion control, some flow control in it to not decode too many frames at once, to not block anything. For synchronization, the queue handles that. It's a few thousand lines of code, so I'm not going to go into the details here, but it handles everything like stream stopping, sending us frames and samples, sudden network issues, and all stuff like this. So it basically enqueues all the frames. Also, it manages the whole flow through the pipeline such that the decoder doesn't decode too many frames at once, and it produces a batch of frames, 1 frame per each input stream, for the renderer to render every few dozens of milliseconds. And API, at first we used the really low-level API, like defining the rendering graphs, but we figured out that most people that are going to use it rather want something more declarative. So currently, it works like this, that you use our API in the declarative API, where you provide what you want to get, similar to HTML. And we run through our layout engine and transform it into the rendering graph, doing a bunch of optimizations in the process. And obviously, we didn't implement the whole HTML standard because we're just for developers, right? And then those rendering graphs are put into renderer. In the audio mixing, it's similar, but just audio mixing is generally a lot simpler. So, what are the drawbacks of using LiveCompositor? Because there are some, certainly. First thing first, hardware decoding and encoding is still work in progress. Currently, we use CPU FFmpeg decoders, but we are working on Vulkan decoding and encoding, such that we could send to the GPU encoded frames, decoded on the GPU, do all the rendering, encode it back, and send only H.264 from RAM to GPU, saving, also reducing CPU usage and saving the bandwidth. Rendering without GPU can be expensive, especially if you are doing a lot of pixel calculations per each frame. For basic layouting, it should be fine to simulate GPU on CPU and run it that way, but if you want to use some custom shaders, doing something like tenderloin effect that we showed you yesterday, it might be quite expensive. And it's new API to learn, right? It's similar. We tried to make it similar to HTML, but yeah, we couldn't implement the whole standard. So something new. So let's take a look what it can do. Here I'm going to run some demos that are available on our GitHub. I will later give you a link for that. So here we just open up camera. We stream it with GStreamer, the camera, to the compositor, and compositor does the whole composing. It does the animations, text overlays, all the layouts, and so on. But you can also use Compositor for other use cases, not only for the video conferencing, but for example, composing TV broadcasts, right? Here we have some final on the green screen, stream with GStreamer, and we remove green screen with our custom shader, and everything else is like built in LiveCompositor. So the text rendering, all those background images are rendered in video in Compositor. We can also modify composition on the fly. So here we have some live streaming demo. Let me just, okay, it should, okay, display it. Let's write here something. And we should see donate popping up. So we've been working on the project for 2 years, and we finally are proud to release it. It's first stable release, especially for CommCon. We just released it today, so you can check it out. Here's a link for our GitHub and for our website. It's called compositor.live, the website. I guess we really like the .live extension out here. And I also want to mention the RTC conference that is happening in September. And I hope to see you all in Krakow. You can get some cool workshops there, from beginners to really advanced ones, from guys implementing Elixir, WebRTC, and Elixir. No-brainer. And with this QR code, you can get 15% off on the tickets. Okay. So if you have any questions, I'm happy to answer them. Just leave this QR codes for if anyone wants to scan them. And I would appreciate if you leave a star on GitHub if you like the project.